Hello everyone. So now we'll solve a problem on shockwave theory. We'll solve a problem on shockwave theory. In this problem, firstly, the upstream flow Q1 is given, which is 2000 vehicle per hour, and speed of the upstream traffic is 80 kilometer per hour. These values are given, and at downstream the accident is occurred and the road is blocked, and we have to calculate the density is given. Density at downstream is 275 vehicle per kilometer, and we have to calculate firstly the shock wave speed, that is shock wave speed VW, and also calculate the rate of Q grow per hour, that will be either N1 or N2. We have to calculate. So first of all, to calculate the shock wave speed, we have to calculate in the solution. We have to calculate the upstream density. The upstream density Q1 will be, we know that the density is the flow divided by speed. Our flow is 2000 and speed is 80 kilometer per hour. So 2000 divided by 80 will give us 25 vehicle per kilometer. This will be the upstream density K1, and V2, the speed at the downstream, since it is road is blocked, the V2 will be 0. Since the V2 is 0, so our Q2, we know that the Q2, that is flow at downstream, will be K2 into V2, that is our density in and speed at the downstream. So this will be also 0. So at the upstream, our density is 25 vehicle per kilometer. At downstream, that is at 2 number segment, the speed is 0 and flow is 0. Now we know that the shock wave formula VW is Q2 minus Q1 divided by K2 minus K1. The Q2 is 0 as we obtained here, and Q1, that is upstream flow, is 25, K2 is 275, and K1 is 25. So calculating this, the VW, that is shock wave speed, is minus 8 kilometer per hour. This is the answer. Since it is minus, so we can say that the Q grows against traffic. If the shock wave speed is plus, in that case Q will grow towards the traffic. However, it is minus, so the Q will grow against the traffic. So this is the first answer, that is minus 8 kilometer per hour. That is our shock wave speed. Now we have to calculate the Q growth rate. Say it is N1 for upstream number of traffic. That is N1 is equal to V1 minus VW into K1T. We know that the number of traffic in the upstream segment equal to V1 minus VW, that is shock wave speed, into K1 into KT. Again, we know that the V2 minus VW K2 into T will be same as N2, because N1 and N2 will be same, because number of vehicle at the upstream and downstream will be the same, because there is no off ramp or on ramp traffic. So dropping T, or let T1 equal to 1, or dropping T, whatever we do, our equation become V1 VW into K1 equal to V2 VW K2. So the V1, that is speed at upstream, it is given 80, and VW is 8, that is minus 8, that becomes plus, and K1, that is 25, and V2, the value of V2 is given the value of V2 is given. The V2 we calculate is 0 and VW is minus minus plus 8 into K2. The K2 value is calculated as 275. So calculating this, we get 88 multiplied by 25, that is 2200 vehicle per hour for N1. Similarly, 8 multiplied with 275 will give us 2 220 that is 200 to 2200 vehicle per hour. Both case it will be similar, so the Q growth rate will be, so Q growth rate will be 2200 vehicle per hour. This is the another answer. So this is the math for shock wave theory. So hope you figure out the entire math. Thank you.